fish stocks are at the lowest levels, and experts blame factors such as Chinese hydropower projects upstream for the dramatic drop in water levels. The situation along the lower Mekong is alarming, severely threatening food supplies for millions in Southeast Asia.
The Mekong River, the largest waterway on the Indochina Peninsula, stretches more than 2,500 miles, originating in the Tibetan Plateau and flowing through countries like Myanmar, Laos, Thailand, Cambodia, Vietnam, and China. While this river sustains millions, we're particularly focused on its path through China. Why? Because China has constructed a significant number of dams and hydroelectric plants along the Mekong, some of which are massive. The vast network of dams and hydroelectric plants plays a crucial role in China's energy needs, but as we'll see, it comes with serious consequences for the countries downstream. Let's dive deeper into how these dams are affecting the Mekong and why the situation is drawing alarms. Let's begin by looking at the Xian Dam. This massive structure, located in China's Yunnan province, is an arch dam completed between 2002 and 2010 at a staggering cost of $3.9 billion. Standing at 960 feet tall, it ranks among the 5 highest dams globally. The Xian Reservoir can hold an astonishing 4 trillion gallons of water, with its hydroelectric capacity of 4,200 megawatts. The dam generates 19 terawatt-hours of electricity annually. This power generation helps China save 6.9 million tons of coal each year, cutting 13.5 million tons of CO2 emissions. Yunnan Province is a vital agricultural region for China. Its warm climate supports the growth of crops like tea, coffee, sugarcane, tobacco, and rice, which can be harvested up to 3 times a year. In fact, by 2020, Yunnan had 10 million acres of farmland dedicated to grain cultivation. The province's fertile lands are crucial to China's food security. However, while the reservoir supports agriculture locally, downstream nations are facing far graver consequences due to the dam's operation. The impact of the Xian Dam's operations became glaringly evident after it began functioning in 2011. The following year, an intense drought affected 4 countries, Thailand, Cambodia, Vietnam, and Laos, where nearly 65 million people rely on the Mekong for water and food. The region, heavily dependent on the Mekong, was devastated as water levels dropped, leaving crops unwatered and populations without adequate drinking water. By 2016, Cambodia faced severe water shortages, with 18 out of 25 provinces impacted. In Thailand, 21 people died due to extreme heat, and in Vietnam, nearly 2 million people struggled to find drinking water. The drop in river levels also led to salt water encroaching into the Mekong Delta, devastating 10% of Vietnam's rice crops. China, however, denied responsibility, claiming that the drought was caused by exceptionally dry weather and not by their dams. While the dispute continued, the question remained, was China's assertion accurate? To answer that, we'll look at more recent data. From 2019 to 2021, a significant lack of rainfall worsened drought conditions for the downstream nations. However, the situation was exacerbated by China's dams holding vast amounts of water. Between China's Xian and Huazhou dams, more than 50% of the Mekong's active water reserves were stored. In 2020, the driest year on record, these dams could have alleviated some of the drought's effects by releasing water during the rainy season, but they chose not to. Instead, China prioritized its own needs. In 2019, the Stimson Center, a Washington-based think tank, published a report pointing to China's dams as a primary cause of the drought affecting the Mekong's downstream countries. The report, based on satellite imagery from the company Eyes on Earth, painted a concerning picture. These infrared images clearly demonstrated the drought's progression, revealing that while China's part of the river was well maintained, countries downstream faced severe hardship. In 2019, the Mekong's flow dropped to its lowest levels in a century, making it the worst year for the lower Mekong basin. The consequences were devastating: failed harvests, declining fish stocks, critical as fish provide a primary protein source for millions, and increased social unrest. Local authorities in the affected countries declared states of emergency, as the damage from the drought was palpable. So, what was happening in China? While the rest of the Mekong River basin suffered, China's dams remained full, and the country's climate was comparatively wetter due to higher than usual rainfall and snowmelt. Yet, most of this water went directly into China's reservoirs, further depleting the flow for downstream nations. This strategy of hoarding water has sparked significant concerns about China's control over the river. In essence, China's dams are disrupting the entire Mekong ecosystem, impacting not only agriculture but also the environment and local communities. For years, China has avoided joining international conventions or agreements that would limit its authority over the Mekong's water resources. Despite the growing dissatisfaction of downstream nations, China maintains that its actions are justified, citing the need for energy production and regional development. In fact, China has consistently rejected claims that their dams are to blame for the diminished flow, including the most recent rebuttal from the Global Times, which defends the dams as crucial, especially during the rainy season. However, other independent studies, such as those conducted by the University of Colorado at Boulder, support the idea that large dams significantly affect regional climates and water flow patterns. In North America, for instance, research spanning over 30 years has shown that the construction of major dams has a direct impact on precipitation patterns and water availability. It's safe to say that the negative effects of dams on the environment are becoming increasingly clear, and China's refusal to acknowledge them is becoming harder to justify. But what happens when China decides to release water from its dams? It's not always the case that water is held back. In fact, sometimes the flow of water from the Mekong's dams increases sharply. During periods of peak electricity demand, China releases stored water, raising the water levels of the river. Even during droughts, a study that analyzed nearly 100 years of hydrological data found that, in recent years, the water levels on the Laos-Cambodia border have risen by 3 to 5 feet during droughts. This artificial increase in water flow has detrimental effects on local ecosystems, especially when it disrupts the natural water cycle. For instance, the trees that typically grow along the riverbanks, which are adapted to seasonal flooding, have been negatively impacted. These trees rely on the fluctuation in water levels for survival, with low water levels allowing new saplings to take root. However, when the water level stays high for too long, it disrupts the growth cycle, causing many trees to die. The same problem extends to the fish, birds, and other wildlife that depend on the forests along the river. While China's actions are certainly damaging, they are not the only contributing factor to the Mekong's problems. Laos, for example, has been rapidly expanding its own hydroelectric industry, building over 60 dams on the Mekong's tributaries by 2016. One of the most significant projects, the Zaiburi Dam, has been the subject of extensive controversy. Environmentalists argue that the dam could severely disrupt fish migration and affect ecosystems downstream. Despite claims from developers that they've taken measures to mitigate the impact, such as installing fish ladders and sediment gates, the river has still suffered. In some areas, the once brown Mekong River has turned an unnatural bright blue, signaling the loss of vital sediment, something known as hungry water, which causes erosion and further environmental damage. The Mekong isn't the only river where hydroelectric projects are causing conflict. A similar scenario is unfolding in Africa, where Ethiopia has built the Grand Renaissance Dam on the Blue Nile. This has sparked a heated dispute with Egypt, which heavily relies on the Nile's waters. Egypt claims that the dam threatens its water security, while Ethiopia argues that the project is crucial for its development and will provide electricity to millions. The situation mirrors the Mekong, where one nation's dam-building ambitions are jeopardizing the future of its neighbors. The situation with the Mekong River presents a complex and multifaceted issue. While hydroelectric power is often seen as a clean energy alternative, the environmental and social costs of large dams cannot be ignored. China's dominance over the Mekong's water resources has sparked tensions with its neighbors, and the long-term consequences of these actions are becoming more evident with each passing year. Until there is greater cooperation and regulation regarding the construction of hydroelectric plants, the future of the Mekong and similar rivers around the world remains uncertain. The need for balanced, sustainable management of these vital water resources has never been more pressing. Jiangsu Province is one of China's economic powerhouses, ranking among the top in industrial output, agricultural production, and living standards. covering 39,600 square miles. Jiangsu has long been a key part of China's history, with Nanjing, its administrative center, serving as the national capital multiple times. As of 2020, Jiangsu had a population of around 85 million, and for some of them, a massive new reservoir system has been built. This project is truly impressive. The upper reservoir, perched on a mountaintop, is enclosed by towering 600-foot-high walls and holds 4.5 billion gallons of water. Below it, another large reservoir helps ensure water supply stability. But why did China build these reservoirs, and how will they benefit millions? Jiangsu's economic strength is undeniable. In 2022, its GDP reached 12.29 trillion yuan, or $1.83 trillion, making it the second largest provincial economy in China, just behind Guangdong. To put this into perspective, Jiangsu's economy surpasses that of Australia and South Korea. If Jiangsu were an independent country, it would rank among the top 15 economies in the world, highlighting its immense economic influence. It's also China's wealthiest province in terms of GDP per capita. In 2022, its nominal GDP per capita crossed $21,000, making it one of the most affluent regions in China. However, this wealth is not evenly distributed. Southern Jiangsu, home to cities like Nanjing, Suzhou, and Wuxi, is significantly more developed and wealthier than the northern part of the province. These cities are major industrial and technological hubs, attracting domestic and international investment. Suzhou, for example, has a strong presence in advanced manufacturing and electronics, while Wuxi is a key center for biotechnology and software development. With its high GDP, robust industrial base, and technological advancements, Jiangsu plays a crucial role in China's overall economic growth, contributing significantly to national exports, research, and innovation. With great wealth comes booming industry and agriculture. Jiangsu has an advanced irrigation system that supports rice, wheat, and corn production. For export, it cultivates cotton, soybeans, peanuts, sesame, and tea, along with silk, which remains a key industry, particularly around Lake Tai. Jiangsu's industrial sector is equally impressive. It has coal, oil, and natural gas deposits, but its most valuable resources are non-metal minerals like halite, sulfur, phosphorus, and marble. These resources fuel industries that require vast amounts of energy. A region as developed as Jiangsu needs an enormous amount of electricity. A significant portion comes from other provinces, including via an ultra-high voltage DC transmission line from the Baihetan Power Station, a massive hydroelectric facility with an installed capacity of 16,000 megawatts. It generates approximately 60.2 billion kilowatt hours of electricity annually. Jiangsu has also invested in renewable energy, including wind farms like the Rudong Wind Farm, which produces around 375 million kilowatt hours per year, reducing CO2 emissions by 247,000 tons. However, despite these efforts, the province still heavily relies on coal and oil. This dependence is problematic due to its flat terrain, low elevation, and high population density. Jiangsu is particularly vulnerable to climate change and rising sea levels. From 1961 to 2007, the province's average temperature rose by 0.38 degrees Fahrenheit per decade, and rainfall has increased, intensifying extreme weather events. These climate shifts threaten agriculture, water resources, transportation, and coastal areas, making energy security a pressing concern. To address these challenges, China constructed the Jurong Pumped Storage Power Station. Approved by China's National Development and Reform Commission in 2016, construction began in 2018, culminating in a groundbreaking energy facility. The station consists of two reservoirs, one at the mountaintop and another on Lunnan Lake. The upper reservoir's main dam stretches 2,650 feet and holds over 4.5 billion gallons of water. The lower reservoir is slightly larger, with a capacity of 5.2 billion gallons. This is a pumped storage hydropower station, PSH, meaning it operates by cycling water between the reservoirs. During low electricity demand, excess power pumps water to the upper reservoir, storing energy. When demand peaks, the water is released, driving turbines to generate electricity. Jurong's design ensures substantial energy output. The system includes 6 single-stage vertical pump turbine units, each rated at 225 megawatts, producing a total capacity of 1,350 megawatts. Additional infrastructure includes an underground power station, a water supply system, and a surface switching station. The project's cost, 9.6 billion yuan, $1.3 billion. But the benefits outweigh the price. By March 2025, 4 of the 6 units had begun operation, with the remaining 2 set to launch by the end of the year. Once fully operational, the station will generate 1.35 billion kilowatt-hours annually, enough to power about 360,000 households. Moreover, it will cut CO2 emissions by 357,000 tons and reduce coal consumption by 134,000 tons per year. To distribute this energy efficiently, 13 miles of power lines and 53 iron towers were built, connecting Jurong to the national grid. This additional infrastructure enhances energy security and contributes to the Yangtze River Delta's shift toward low-carbon energy. However, constructing this facility was far from easy. Half of the power lines had to be built in mountainous terrain, requiring innovative methods to minimize environmental impact. Advanced construction equipment, such as visual tension devices and digital cable processing tools, ensured minimal damage to local vegetation. Builders also faced geological challenges, including karst sinkholes and unstable diorite rock formations. To overcome these, engineers used advanced detection technologies like borehole TV imaging and seismic CT scanning, identifying and reinforcing weak areas with pre-stressed anchor cables and rods. Another impressive aspect of the project was its efficient resource use. Nearly all materials for the upper reservoir were sourced from a nearby excavation site, achieving a remarkable 99% utilization rate, cutting costs and reducing environmental disruption. Jurong's location, 40 miles from Nanjing and 22 miles from Zhenjiang, ensures that its clean energy benefits densely populated, high-demand areas. Nanjing alone has over 9 million residents, many of whom rely on agriculture, forestry, and fishing, sectors that demand significant water and electricity. The Yangtze River provides water, but irrigation and processing infrastructure require a steady energy supply. In 2019, these industries generated $6.5 billion, reinforcing the importance of reliable power. This PSH model isn't new to China. The Fengning Pumped Storage Power Station in Hebei, which began operations in 2019, is the largest in the world, with a capacity of 3.6 gigawatts. Originally built to support the 2022 Beijing Winter Olympics, Fengning now plays a crucial role in stabilizing northern China's energy grid. Located near Beijing, a city of 22 million people, Fengning helps offset reliance on fossil fuels. Coal still dominates Beijing's energy mix, accounting for 40% of electricity production. Although coal consumption has been gradually reduced, Hebei Province, surrounding Beijing, burned over 300 million tons in 2011, more than Germany's entire coal usage. While China is transitioning to renewables, fossil fuels remain a significant part of the energy landscape. Projects like Fengning and Jurong provide a path forward, balancing clean energy storage with peak demand management. Jiangsu's economic success hinges on stable and sustainable energy. The Jurong Pumped Storage Power Station represents a critical step toward reducing reliance on fossil fuels while ensuring energy security. By integrating clean storage solutions, China continues to innovate in tackling climate challenges and powering its economic hubs. This ambitious engineering feat may soon serve as a model for future energy storage projects worldwide, proving that large-scale solutions can address both economic and environmental challenges.